Hello friends, continuing with the topic of transistor, today we come to next part of it, transistor as an oscillator. Previously we have studied about the applications of transistor as switch, transistor as an amplifier. Then we have studied about feedback amplifier, which was essential to understand about an oscillator. Now we come to transistor as an oscillator, which is another application of transistor. Now first point, introduction. External input is necessary to sustain output in case of an amplifier, but in case of an oscillator, output is available without any external input and is self-sustained. I repeat, external input is necessary to sustain output in case of an amplifier, but in case of an oscillator, output is available without any external input and is self-sustained. Second point, requirements to form an oscillator. So what are the requirements to form an oscillator? First, we need an LC oscillator circuit with frequency given by the formula f is equal to 1 by 2 pi root LC. Second, we need an amplifier. Third, positive feedback to compensate I square R loss in inductor L of oscillator circuit. So these are the three basic requirements to form an oscillator. Third, collector tuned oscillator. Basically, oscillators are of many types, like Armstrong oscillator, Hartley oscillator, Colpit oscillator, and so many other like crystal oscillator. But here we are going to discuss about collector tuned oscillator. A collector tuned oscillator circuit using NPN transistor. Here is the circuit where TR is transistor amplifier, T is a transformer comprising of LP and LS and LF. LS is secondary across which oscillator output is taken. LP is primary winding. C is a capacitor in parallel with LP, forms oscillator circuit generating damped oscillations of frequency f equal to 1 by 2 pi root LC. LF is feedback winding providing 180-degree phase shift due to transformer action. VBB, this is VBB, is base bias battery. VCC, this is VCC, is collector bias battery. S is a switch, on off switch, because tuned circuit, that is parallel LC circuit, is connected with collector, hence it is called as collector tuned oscillator. If it is connected with base, then we will call it as base tuned circuit. Okay, but here it is connected with collector of the transistor, so we call it as collector tuned circuit. Now B, how oscillations are built up. First point, surge. When switch S is closed, a surge of collector current IC flows through LP. This current reach maximum value instantaneously, that is from X to Y, resulting into growth of magnetic field in LP. Resulting into growth of magnetic field in LP from 0 to maximum value, which is changing magnetic field. It causes an induced EMF to set up across LP. Now second, growing magnetic field and induced EMF and saturation state. During growth of collector current and magnetic field, an induced EMF set up across LP with polarity say and D becoming negative and E becoming positive. Capacitor C gets charged and also an induced EMF is set up across feedback winding LF with polarity and B becoming positive and A becoming negative. Due to this feedback, base bias increases, resulting into increase in base current, which causes collector current IC to increase, increasing induced EMF, increasing feedback, increasing base current once again, increasing collector current till collector current reaches saturation value from X to Y and base current reaches from X dash to Y dash. The transistor reaches saturation state. Third, decay of magnetic field, induced EMF and cutoff state. Let us see how transistor reaches cutoff state. Now, no more changing magnetic field exists since it reaches saturation value. As a result, no more induced EMF exists in feedback winding LF. The magnetic field in LP starts decaying, collector current starts reducing, capacitor starts discharging through LP, and an induced EMF in opposite polarity is set up in LP as well as LF, with D becoming positive and E becoming negative, B becoming negative and A becoming positive. Base bias now reduces due to reverse bias through feedback winding, causing base current to reduce, which results in reduction of collector current. It further increases feedback, which reduces base current to Z dash, resulting into further reduction in collector current to Z till collector current becomes 0. Transistor reaches cutoff state. Now fourth, oscillation sustained. The process restarts and transistor reaches saturation state and alternately to cutoff state. Hence, oscillations between saturation to cutoff state are sustained. Hence, transistor oscillates between saturation to cutoff state. I repeat, the process restarts and transistor reaches saturation state and alternately to cutoff state. Hence, transistor oscillates between saturation to cutoff state. Thus, oscillations are sustained. Fifth, positive feedback. 180-degree phase shift is provided by the feedback winding and 180-degree phase shift is provided by the transistor itself, being in common emitter configuration. Now, since we know in a transformer 180 phase shift is introduced between primary and secondary, and also a transistor when used as common emitter amplifier, input and output signals are out of phase. So therefore a total 360-degree phase shift is provided by the circuit. Therefore we say it is positive feedback. Thus loss due to ohmic resistance of LP is equally compensated. That is, feedback is equal to loss. When feedback is equal to loss, then oscillations are sustained. If feedback is less than loss, the oscillations damp out. If feedback is more than loss, then it becomes unstable. So therefore feedback must be equal to I square or loss, where R is the resistance of primary winding. Sixth, frequency of oscillation. Frequency of oscillation is determined by the values of L and C and is given by the expression F is equal to 1 by 2 pi root LC. Okay. Now assignment 14 continued. Question number 70. Describe briefly with the help of a circuit diagram how an NPN transistor is used to produce self-sustained oscillations. Question number 71. With the help of circuit diagram, explain the working of transistor as an oscillator using PNP transistor. Question number 72. What is feedback? Derive an expression for the voltage gain when negative feedback is applied to an amplifier. What are advantages and disadvantages of this type of feedback? Question number 73. What is feedback? Derive an expression for voltage gain when positive feedback is applied to an amplifier. What are advantages and disadvantages of this type of feedback? Thank you so much. Here we finish with transistor. Next time we'll take up logic circuit. Till then, goodbye and good luck to you.